Hello everyone, I'm here with Ayal Yogev, the founder and CEO of Anjuna, a new cybersecurity startup. So first of all, Ayal, thank you so much for being here with us inside of, your home for now, the Playground VC offices. It's a wonderful space and I'm sure you're really happy to have your team out here. There's so many different new layers of technology. I mean, 25 years ago, so we've had sort of normal computers, but then now mobile, you've had cloud, describe how that impacts the cybersecurity space.
Yeah, so at a very high level, every time there's a new technology, you need the security layer around it to protect it because it's going to become a target. And as sort of things shift, we get these sort of opportunities for attackers to come in because the old security might not be a good fit for kind of the new environment. And yeah, we've seen that with the move to, well, essentially the internet was sort of the first example. Once people started connecting their networks to the internet, this was an opportunity for attackers to come in, and that's why the firewall was built. We've then seen the same with mobile. We've seen the same with the move to the cloud. We're actually seeing it now with connected cars, where people are basically trying to break in, and now there's sort of a niche in security around protecting connected cars. Every technology advancement that happens, builds a security industry around it.
And so now you have sort of the dual complexity, right? More and more places or infrastructure to protect, and attackers are getting more and more sophisticated. I mean, this is getting really, really a lot more complicated than when you started 20 or 25 years ago.
It's true, but I also have job security. There's always going to be a need for security.
There will always be a need for security. That's true. That's very true. So tell me about the motivation to start Anjuna.
Yeah, so I started Anjuna by I reconnected with my co-founder who we met over 20 years ago in the Israeli intelligence community, and he ended up doing his PhD at Stanford with Professor Dan Boneh, who's I'd say the top cryptographer on the planet today. And that's where he ran into something called confidential computing. And he got super excited. He came to talk to me about this, and I also got super excited, essentially for two reasons. One was, again, I've been in security for a long time, and when you kind of run into security problems, when you peel the layers of the onion, you always get to that same core security problem. And that core problem is that once somebody gets access to the infrastructure, once somebody has root access or physical access, it's game over. There's nothing you can do to stop that. And finally there was a solution, and that got me super excited because this kind of solves the core problem of security. Whereas a lot of the security tools that were built today are these sort of band-aid solutions to try to kind of stop you from getting that level of access. And suddenly there's a solution. The other reason that got me super excited was security in general is sort of an enabler, right? If you have the right level of security, you can do things that you couldn't otherwise. If you couldn't protect credit cards online, like Amazon couldn't have existed, right? If you didn't have security and trust in your bank, like the banking industry wouldn't have existed. Right? Security's always been an enabler. And what's nice about this new confidential computing is it's essentially an enabler for kind of the next big shift in compute, basically allowing you to run workloads in any environment, in every location, which is just a huge shift that's not going to kind of reshape the world of security, but also the world of compute. So that's why I decided to kind of leave what I was doing and go start the company.
So let's peel back this layer by layer. Confidential computing. Can you describe for the audience what is it, and maybe use a use case to describe how it works at a high level?
Yeah, of course. So that core problem that I said, once you have root access, you have access to everything, stems from the fact that any application, in order to process data, has to sort of decrypt the data and load it to memory to process it. At that point, the data is completely exposed. So, and that has always been sort of the core problem. And regardless of how you try to protect against it, whatever software solutions you use, even if you encrypt data, the keys have to live, in the memory to decrypt the data, and the data gets loaded to memory. And whatever software you use, if you have root access, you can bypass them. There was never a solution.
So that's what you mean by, in the core of it, that was always the problem. So you would protect the outside, right? So don't steal the passwords. You would protect the outside of the environment, but anytime you got in, that fundamentally was a problem.
Yeah, and a lot of security, that's why I said a lot of security was basically these patch or band-aid solutions. It was things like perimeter security, like the firewall. It was kind of preventing you from coming in, but once you're in, you're in. And what confidential computing essentially enabled is finally protecting that the memory while it's being used, which effectively means even if somebody gets root access to a system or physical access, they can't get access to the data or the code running on top, processing that data, which is just a game changer in terms of what you can do.
So, Ayal, you've talked to me, even if you got my phone, right, my physical phone, and you had it, which obviously has a lot of confidential information on there. I mean, you'll know when I get my next haircut. There's all sorts of crazy things in there. No, I'm just kidding. So it has confidential information in there. But with confidential computing, you can't access that even if you have my physical phone. Is that how I should think about it?
Yeah, so that's actually how confidential computing started to some extent. It's actually started on the phones. And I don't know if you ever thought about what happened if you lose your phone, right? You have your...
It's a scary thought.
It is, but it's easy to do, right? You carry it around. It's very easy to go lose your phone, and it's even beyond your data, which is obviously extremely sensitive. Like your next haircut is sensitive, but it's also around your fingerprint or Face ID, right? You have biometric data on the phone, and you can change your password, but you can't change your fingerprint. And what Apple and Samsung and the other vendors have done is that they've used a confidential computing environment on the ARM chipset, something called Trust Zone, to make sure that even if somebody does get physical access to the phone, they're not going to be able to use that to get access to the biometric data. And that actually is what allowed, I don't know if you remember the case with Apple and the FBI a few years back, where the FBI got access to a phone after the Boston terrorist attack, one of the phones of the terrorists, and wanted to unlock it. And they went to Apple saying, we physically have the phone, can you go unlock it for us? And people remember that Apple said, we won't help you. But what Apple actually said was, we can't unlock the phone even if we have physical access. And the reason they said that is because of that confidential computing environment. And what sort of happened in the industry is that technology moved to the server side because that's where the real sensitive data is for organization. It's not the endpoint, it's the server side. So now we have the same capabilities on server CPUs coming out from Intel and AMD, and we can use that same technology to protect essentially every workload, every application in any environment.
So you really created Anjuna to take advantage of this confidential computing concept. So what does Anjuna do?
Yeah. So at a high level, every time there was a major shift in in hardware architecture, you needed a software stack on top of it to just make it super simple to use. And I guess the best example is virtualization and what VMware has done for virtualization. Virtualization was this major shift in how we do compute,
Absolutely.
right? And to some extent, without virtualization, we wouldn't have the public cloud. You can't have a public cloud without this layer of virtualization. But when virtualization first came out, very few people were using it because it was so difficult. You had to go refactor every application. It just didn't make any sense. And what VMware has done is build a software stack to just make it super simple to virtualize everything. And then within a few years, there are very few workloads that are running unvirtualized today. And we do exactly the same for confidential computing. Again, a huge shift in hardware architecture that allows us to kind of take compute to the next level. Extremely difficult to use. You have to go rebuild every application, which no organization wants to do. We build a software stack that allows you to just run everything in confidential computing with no changes.
Now that's really interesting because you're taking this sort of fundamental shift and then making it easy and accessible so all organizations can do it. So what's the type of an organization or a customer that you can talk about that uses Anjuna's systems?
Yeah, so I'll give you
software.
Yeah, financial services is one, oil and gas. So that's actually G2000s. One that I actually wanted to talk about because I think it's one of the best examples. Actually, closing a loop for me is the Israeli Ministry of Defense is one of our customers, and they're using us. They're able to move sensitive data to the commercial cloud for the first time using our technology. And they're essentially using the commercial cloud with the security and privacy of a gov cloud using confidential computing, which is just extremely, extremely exciting.
Well, this is one of the fascinating things about what you're doing is that you're enabling all these companies, governments, industries that had this extraordinarily sensitive data who had to use a different, higher priced infrastructure before, didn't have all the ease and the tooling that is in the public cloud. And what you're enabling all of them to do with Anjuna is to move it from their more expensive solutions without maybe the sophisticated tooling, again, in the public cloud. And you're enabling them to move it to this very, very different cost base, but a very different feature base as well.
Exactly.
And when you're one of your customers that you can talk about is a government defense agency, which clearly has sensitivity around the information it's moving around. I mean, that's a remarkable statement about confidential computing, but also Anjuna as a solution to be able to access that type of security. I mean, that's really remarkable.
Yeah, and actually it's even more, like, not only do they have probably some of the most sensitive data you can think of, this is one of the most sophisticated organizations on the planet in terms of being able to assess what's secure and what's not secure. And the fact that they're using us to move this is just an amazing, vote of confidence. And the fact that one of the challenges that a lot of security companies face is that not many customers want to be public references because they don't want to advertise what security tools they're using. So people won't be able to use that to get access to the data. The fact that they felt confident enough to say, to publicly, to be a public reference for us and publicly say, yeah, we're using this, kind of shows the level of security that that this has.
Ayal, tell me one thing as we sort of come to close here. When you look forward 5 or 10 years in the cybersecurity space, what do you see? What's coming for the world?
Yeah, so kind of going back to this, and this is why this is why I went to confidential computing. Once you have confidential computing, you basically solved one of the core problems of security, which means that all these 80% of solutions are basically band-aid solutions are not necessarily needed anymore. And one of the nice things about confidential computing or any security solution that has no performance impact and is super simple to use becomes a default over time. Just because, why wouldn't you use it, right? We've seen that with HTTPS, right? 10 years ago, no website with everything was just HTTP. Today, everything is HTTPS. And CNN.com is using HTTPS not because there's anything sensitive on a news website, but because if it's a chat, why wouldn't you use security and privacy if you can just check a box and you get it? I think that's what's going to happen with confidential computing. It's just going to basically protects the memory. It's going to protect everything across the board. And once you have that, data is never exposed. Data is never accessible. So I think the entire security industry is going to kind of rebuild around this, where you can get rid of a lot of the old things and build much more sophisticated things on top of this.
Wow, yeah. Well, thank you for meeting with us today to talk about what Anjuna is doing, but also to talk about sort of what has happened in cybersecurity industry and what is going to happen. It's been exciting, a great conversation.
Thank you.